This is Geometry Semester 2. It's a unit called Pythagorean Review. It's number 10, so it's on down the list in units. Number 10, Pythagorean Review. And it's the 5th lesson called Heights of Triangles Practice. It's on creatormath.com under the Geometry tab. You might have to type in creatormath.weebly.com into Google to find the site. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So, I might be able to model that for you a little bit. See if this is visible. So creatormath.weebly.com. Here's what the home page looks like. Click Geometry to go to the Geometry tab. Pass by the vocabulary. Here's the all-important PDF list of all the vocabulary for the course for this semester. Go to Semester 2, Table of Contents. This should be written into pages 2 through 6 of your composition book a long time ago by now. If not, you're going to write in this entire table of contents, and we're going to go down and find the unit we're in. That tells us what pages all the units are on and the lessons. Here we go, Pythagorean Theorem Review. So we've already covered Pythagorean Theorem. This is a review of the topic, so we'll go a little bit quicker. There's 1, 2, 3, 4, 5 lessons in this, and this one's actually called Heights of Triangles, number 5, so, and Distance Formula. So there's page numbers here of where these notes go. There'll be notes on this tab right here, where these notes go on in your composition book, and then this video will be tagged to this right here. Right? Don't follow the page numbers from this video, follow the page numbers from the actual table of contents during the time that you're taking the course, because it will change over time. Well, so the interesting thing about this lesson, although we are in a Pythagorean review unit, one of the things we found is that students have trouble with similar triangles, and so this is actually a similarity lesson embedded in the Pythagorean unit. And the only excuse I have for that is that students often struggle with similar triangles, so we kind of start to introduce it early as part of the Pythagorean rollout, even though it's not Pythagorean at all. It's proportional or similar triangles. So with that said, what is a proportion? A proportion is one fraction placed equal to another. So if we have 1/2 equal to 2/4, this is a proportion. This is a fraction, and it's placed equal to a fraction. These fractions are equal. This one is 1/2, and if simplified, 2/4 is 1/2 also. So this is a valid statement. But this is what a proportion is. And you often hear this idea of cross multiply. And in all fairness, that's really not much of a cross right there. That's more of an X. They should call it X multiply, but I don't know. Who knows? I can't reinvent the geometry topic, so we call it cross multiply when we can multiply across these terms. 1 times 4 is going to be equal to 2 times 2. And sure enough, 1 times 4 is 4, and 2 times 2 is 4. So that's what a proportion is, one fraction placed equal to another. So given a person that's 6 feet tall, find the height of the tree using the shadow created by the sun. So here's a tree here, and I apologize for my drawing ability. There's a tree. The sun is beaming down and creating a shadow this way. This person stands right here, and the shadow lines up right with the top of the person's head right there. Exactly, right? And we're going to say exactly. It says the person's 6 feet tall, so this is 6 feet here. And then we measure to where the shadow ends. It's 10 feet here between the person and the shadow end, and it's 30 feet here, and I'm not totally sure whether that's 30 is the entire distance. I'm thinking because it's written above the line, the 30 is the distance between the tree and the person. So I'm thinking that this entire distance is 30 plus 10 is 40 feet, and we'll find out. I might be wrong on that. I don't remember for this one. So we're going to create a proportion, because what happens is there's a triangle here. There's a triangle here, and this is called a nested triangle because it sits inside of the bigger triangle. They share the same angle here. That's what this is pointing to here. The angle of the smaller triangle and the angle of the larger triangle are the same angle. They're identical. So therefore we know we have what's called proportional or similar triangles. And just on a side note, let me find one of my old trusted models. This is a scale model, right, of a helicopter. I don't know if you can tell. It's been through the weeds. I've used it for years. So this is a scale model. Scale model is one thing like another. It's proportional in all aspects. So if you look at the real helicopter, it looks just like this. And you look at the smaller one, it looks just like the real one. All right, so that's what proportional or similar means in terms of triangles. These two triangles are the same shape but are different by a scale factor. So let's see what we do here. We go ahead and create a fraction equal to a fraction. So I'm going to do a fraction bar. A fraction bar literally means divided by. So if you had 1/2 here, it's 1 divided by 2 is what a fraction bar literally is. It could be per in terms of a ratio. But let's go ahead and set up a ratio here. We're going to take this side. So we want to know how high this tree is, right? We're going to call that x. How high is the tree? X. So it looks like we've got 6 over 10 is going to equal x over the entire distance here. I'm going to go with 40 at first, and let's see if we're wrong about that. I don't think they mean 30 for the whole distance because the way they wrote this in the middle of this dimension. So let's just see. So what happens here? We can cross multiply, and we get 10 times x, 10x equals, the equals in the middle, and 6 times 40. 4 times 6 is 24, so we get 10x equals 240. If I got that right, we divide both sides by 10. And x equals, get rid of the zeros, we get 24 feet. So it's sure enough 24 feet. It looks like we were correct in our assumption that we're going to add up both of these dimensions to get the total dimension of that larger triangle. And just so you can see, the larger triangle looks like this, right? It's the smaller triangle that looks like this. So we were able to take, and notice we went in a very specific pattern. We took the height of the smaller triangle, and that was on top in the numerator position. Therefore, the height of the larger triangle is also in the numerator position. Then we took the distance to the end of the shadow of the smaller triangle was in the denominator position of 10, and also the entire distance of the tree to the end of the shadow, being the 40 feet, was in the denominator of the other fraction. These two fractions must be equal. That's the idea of this concept of being proportional or similar or equal. Oops, I'm sorry. I didn't show you that. I drew out the large triangle here. Notice they're right angles on both these, so they're both two right triangles, and there's a smaller one nested inside of the larger, and they share this same angle. Okay, same angle. And that's what helps to make them similar, which we'll cover in the similar triangles section on what makes two triangles similar or proportional. So we're going to repeat this problem several times in slightly different ways. This again gives us a 6-foot tall person, so we know this is 6 foot. This gives us the same dimensions, 30, and it asks us to, what is a proportion which can be set up? And they might have even asked us this first. We went ahead and set one up and solved it. Now we just repeat this. We don't have to go as far as the last time. This was 40 feet. This was x. So we have this thing equal here. They're now using AB. So let's look at the one they gave us. Let's sort of sort through the answer. They gave us AB here. So if this is AB, and that's here, and that's the height of the tree, then we would go straight to the height of the person, which in this case is CD. We'd put that here. Then, oh, interesting. Look, they rearranged it. They said AB over CD. So now they're giving us some options. Let's go ahead and do it our way first. Let's say AB. So I do see why this is second, actually, because it's a little bit harder the way they're giving us the answer choice. We did height and height, both on top. So now let's do distance and distance. Let's do distance of the tree first, because we started with height with the tree. So that's 40, or BE. Let's put BE here. And then the distance here would be, C is D to E. I kind of covered it up. That's a D right there, DE. So what happens in a proportion is all of these positions can be reversed. For example, DE and AB can change positions. In other words, we could write DE over BE, keep that the same. CD keep the same, but now the AB would be here. And I know that's a little complicated. You might have to track through it slower. But what's happening is the AB is switching to this position, the DE is switching here. When you cross multiply, this comes out the exact same answer. So what this is illustrating to us is the ability to move around the positions of the proportion in a cross multiplication format. Now we can also flip both of them and do different things. So let's see where they start with. They start with AB over CD. So can we switch the CD to here? Yes, we could say AB and put it over the CD. That would leave the DE on the bottom over here, and it would move the BE up to this position, so BE. So this is a more difficult problem, the way they're asking us, than the prior one. Just solving the prior one was actually easier than this whole idea of moving positions around. So now I see why this was given second. So if this is AB over CD, that matches this. And does this second one match here? BE over DE. So this is the correct answer. And if you start to look at the others, we can find errors. So CD over AB. So CD over AB. That's not going to work, and I'd probably rather go this forward direction than go the elimination process. I'd rather go this way and see what I can get to match up with what I've created. All right. Let's look at the next one. We still have a 6-foot tall person, 6 feet. We still have the same dimensions here, 10 and 30, so the entire length is 40. And are they still asking us, what is a proportion which can be set up? Okay, so now they're doing the same thing they just did prior, but without the DE and the BE and the actual side lengths. It looks like we're plugging in actual dimensions here. So let's see what we can get here. Let's go back and say, this is x again. Let's say x over 6. X over 6. So if I go, and I'm kind of going by this first one, x over 6. If we go x over 6, then we have to go the same pattern. We went tree height to person height. Now we're going to go tree distance to person distance equals tree distance to person distance, 40 to 10. Sure enough, that matches. So we kind of are cheating a little in terms of just, we can look, if they give us answer choices, we're always sometimes considering going from the answer to the prior or to the prior to the answer. That's always an option in math, is work forward or backward. And I'm kind of choosing the one that's easier in this case. They have a 6 over x. If we were to do this one, just to go this direction, 6 over x would go this direction. See how that's there? Once we went the height of the person to the tree height, we would now have to go 10 over the distance 40. 6 over x equals 10 over 40. I like this one too. Oh, look at this. More than one answer may apply. So I'm glad I'm checking the other ones. This one works too. And all we did was go 6 over x, so we went this direction, then we went 10 over the whole distance 40. And that makes sense. Let's try this next one. X over 6 equals 10 over 40. X over 6 equals 10 over 40. Now, what's wrong with this? If you go x over 6, you're going tree to person. You can't now go person to tree. That's backwards. If you go tree to person, you have to go tree to person. Follow the order. So this one's out. If you went 6 over x, we're going this direction here. Then you would go 10 over 40. So this one's out too. You can't go 40 over 10. A little bit complicated. I'm not sure I'm explaining that totally right, but these two answers are correct in this case. We'd mark 2 of them in our multiple choice assessment we were taking, or practice. All right, let's keep going. Given a proportion of x over 6, what's the result after cross multiplying? So let's draw it out a little bit. Let's write it out the way we might write it instead of type it. The way we type it looks strange to my eye. 40 over 10. Now they're just giving us a proportion, and they're asking us to cross multiply. Well, 10 times x, keep the equals next, and 6 times 40 is 240. So right there, 10x equals 240. And they're not asking us to solve for x, they're just asking us to cross multiply this proportion. All right, now what do we have? Given a 6-foot mailbox. All right, it's a 6-foot mailbox, 6 feet. That looks like a mailbox, kinda, and it says mailbox, so that's how I know it's a mailbox. Find the height of the house using the shadow created by the sun. So here's the height of the house. We're going to call that x. The cool thing about this method is I can't get a tape measure up and measure the house. It's too difficult for me, but if I can measure the mailbox. So if I can measure 6 feet of the mailbox, now I can predict the height of the house as long as my shadow is cast straight down across the roof and just touching the top of the mailbox. If the shadow's going at any other angle, you know, like this or this, it just doesn't work. This whole thing's not going to work. But what I've got is a nested triangle. It's a right triangle here, and it's nested inside a larger right triangle, and they share the same angle just like before. So these are called similar or proportional triangles. So on a proportional triangle, we get to use a proportion. A proportion is one fraction made equal to another. I'll start with the fraction bars. Now I'll proceed to line up the proportional sides. X, the height of the house, is compared to the height of the mailbox. So let's go x over 6. If I compare the height of the house to the height of the mailbox, and let's do this first. Let's take this whole distance is 40 plus 10 is 50 feet. Then I'm going to take the distance from the edge of the shadow, from the end of the shadow of the house first. That's going to be 50. And then the distance of the mailbox next is going to be 10. So I went in a specific pattern. Height of tree over height of mailbox. Distance of, not tree, house. Height of house over height of mailbox. Distance of house from end of shadow over distance of mailbox from end of shadow. I went in a consistent manner, right? I dealt with the house first in the numerator here, so I dealt with the house distance first here in the numerator, and then lined up the others with it. Now I can cross multiply. 10x equals 6 times 50 is 300. Divide both sides by 10, and x equals 30. So the house is 30 feet tall. I like 30 here. Okay, there we go, 30. So, and just to check really quickly, it said the person's 6, right? 6 foot high, or the mailbox is 6 feet. Sorry, I keep going back to the other example. And we want to know the height of the house. Okay, so x. X over 6 equals 50 over 10, and I'm assuming again this is just the portion here because it's written on top and it's right in the middle. It'd be nice if they were clearer on their dimensions here. So this would be 300, I'd say 30. So I'm going to go with this here. Let's see the next one. Okay, now it seems like they're going to run us through the same drill with this. 6 foot high mailbox. This is 6 feet. And they're giving us different proportions, and they are saying more than one answer may apply. Let's start with AB over CD. So here's AB over CD. If AB is over CD, now I'm going to have to go this distance. So AB over CD, now I'm going to have to go the total distance here of BE equals BE over DE. So AB over CD equals BE over DE. That's a correct answer. Let's try the next one. CD over AB. CD over AB. Okay, let's trace it out. CD is the height of the mailbox over AB, so now we're going mailbox to house. So CD over AB is going to be DE over BE. Okay, is that this one? CD over AB equals DE over AB. That one's correct. How about this AB over CD? AB over CD equals what? AB over CD. No, this one would have, this one can't be, this is upside down. This can't be true. It would be like this one if we went AB over CD. Can't be this one. All right, CD over AB equals what? So CD is here, over AB is here. Therefore, we'd have to go DE over BE. DE over BE. And this is upside down. This is wrong. Okay, it can't be, it's got to be DE over BE and not that. So these two answers. A 6 foot high mailbox, what's the proportion we can set up? X, 6 foot. Whole thing is 50 feet. Sorry. Come on. There we go. 50 feet. So if we're going to do X, they do X over 5. Did they change the distance of this, the height of this mailbox? Let's go ahead and change it to 5 feet here. And let's change this to 5 feet. I like that better. So they're going X over 5. So if it's X over 5 equals another fraction, we're going X to 5. So we have to go whole distance 50 over 10. 50 over 10. I like this one. That's my setup. X over 5 equals 50 over 10. Given the proportion of X over 5 is 50 over 10, what is the results after cross multiplying. That's the one we just did. I see the pattern here. That's why I'm going a little bit faster. Well, cross multiply, which really looks like an x to me. 10 times x is 10x. Equals 5 times 50 is 250. I like this one. Okay, just go across the two things in the x, gets separated by an equals. The other part of the x, okay? So a truck is 4 feet tall. Here's a truck. Kind of looks like a truck. This looks like the wheels, I guess, and this looks like the windshield, and looks like the grill. All right. If this is 4 feet, this is 4 feet high right here. How tall is the building? Find the height of the building using the shadow created. The shadow of the sun's going right across the building, down across the top of the truck, and it probably would actually be on this corner out here, but let's go ahead and take their picture. Their picture says 11 feet, so the total here looks like it would be 12 feet. We're going to take x over 4, set up a proportion, equals the other fraction. If we go x over 4, then we're going to go the whole distance, 12 over 1. Cross multiply, don't panic, even though it's a 1. 1 times x is x, and 4 times 12 is 48. So it looks like x is 48 feet. All right, same drill it looks like. Go ahead and find the proportion, more than one apply. I already know what they're going to ask now. I feel like I know what's going on here. AB over CD. So AB over CD. We're going building height to truck height. So now we're going to go total distance, which is BE, over this distance, DE. BE over DE. This one's good. Let's check the next one. CD over AB, and notice it just flipped. It's this one with now the CD on top, so you can flip the second one and it's going to be right. I know this is going to be DE over BE. Is that what they did? DE over BE, so I know this one's right. So now I'm even cutting corners because I've done enough of these now that I can see the pattern. If you flip the first fraction, you flip the second, then that still is a legit proportion. That's one of the options with proportions. You can flip the two fractions. You can't just flip one, you have to flip both. AB over CD is this one here. They've got it upside down, DE, so that one's out. I now see the pattern in their answers. CD over AB is here, got to be DE over BE, not BE over DE. Okay, this is backwards. They reversed it to trick us, and you have to sit there and look a little bit closer than I am. I'm going kind of fast because I see what they're doing now, right? All right, let's see. Let's set up a proportion. We want to know the height of the building. We're told that this is 4 feet, so we have 4 feet here. We know that the whole distance is 11 and 1 is 12, and the distance from the truck to the end of the shadow, and this is to the distance to the end of where that shadow ends. And you know when you walk in the sun, you'll see where your shadow ends very clearly, right? Especially if it's a sunny day. So they started with x over 4. So if I go x over 4 equals total distance over smaller, 12 over 1. So x over 4 equals 12 over 1. Do they flip this? If they go 4 over x is 12 over 1. No, that would have to flip too. If they go x over 4 is 1 over 12. Okay, so that's no flipped wrong because x over 4 is 12 over 1. That's wrong. And if they flip this one, x over 4, they have to flip this one, is 12 over 1. Nope, that one's out too. Isn't this the same as this one? These two are the same and they're both wrong. So I'm thinking it's this one right here, right? X over 4 is 12 over 1. This one says x over 4 is 12 over 1. Nope. And this one says x over 4 is 12 over 1. Nope. All right, so they say more than one answer may apply, but in this case it's not true. All right? I don't think that's true. More than one answer does not apply. They do say may, though, so they do leave some wiggle room there. Given the proportion x over 4, what's the result of cross multiplying? X over 4 equals 12 over 1. Cross multiply. We already did this one. It's x equals 48. Aww. Given the following triangle, D equals 5. D equals 5. This equals 5. Check. E equals 10. Check. B equals 30. Check. What's the Pythagorean theorem set up to find the height of the triangle? F. Ah, this is the first Pythagorean problem in the whole review set right there. So, all right, fine, fair enough. Well, let's start with the Pythagorean theorem. Hint, it's right here. It's height squared equals leg squared plus leg squared. I know you might have learned a squared plus b squared equals c squared, but trust me, learn to write it this way, it's going to be a lot easier. Now all I need is the hypotenuse. So let's pull out this triangle here. Let's redraw it right here, right under our Pythagorean. Here's a right angle, here, 90 degrees. The height of the triangle F is what is our x. We want to know the height. We're told that this side over here is 30, and this side down here, E, is 10. This is a leg because it's attached to the 90. Both legs are attached to the 90, and this side over here is across from the 90, so it's the height, or hypotenuse. The hypotenuse is the longest side and across from the largest angle, which is 90 degrees. So in this case, we have 30 squared equals, because that's the height, one of the legs squared. Let's go ahead and say one of those is 12. One of those is the x, and the other is plus the 10 squared. We're going to subtract 10 squared from both sides. Disappears over here. Remember to keep your equals lined up with a center line. Put an equals here. There's an x squared here. And you get a 30 squared minus 10 squared. We're going to take the square root of the right, which means we have to do that of the left. A square root of a square leaves you with just x equals, and this thing here, square root of 30 squared minus 10 squared. Oh, duh, all they need us to do is set this up right here, you guys. I'm sorry, I'm going and solving it. So let's see, did we get it right? 30 squared equals f, fine, because I used x, but the actual dimension is called f, so f squared plus 10 squared. This one right here. They didn't even ask us to solve it. All right, but if you plug this in the calculator, you can. In fact, maybe just to do that, since we went this distance, go like this. Turn your calculator sideways so you can see the full calculator, and say square root, there we go, 30 squared minus 10 squared equals, x is approximately equal to, I'm going to do a squiggly equals here, a really, really bad one, x equals, there we go, 28.28, let's go 28.3, round it to the 10th place. 28.3, what dimensions are we using? Doesn't say, so units, right? Whoops, 28.3 units. So make sure you're in the right place. You're going to be in creatormath.weebly.com under the Geometry tab, looking at Geometry, Semester 2. It's the unit called Pythagorean Review. Even though this is about similar triangles, it's warming you up for that review. And this is a lesson called Heights of Triangles Practice. Hope that helps.